my keynote, I explained the field of radiation in space and how it is composed, and what are the different sources of radiation, and what they do to human cells, how they interact, how these particles interact with DNA, what kind of damage they produce there, how the cells cope with this damage, and what this means for the whole body. So we have this increased cancer risk, we might have turbidities of the eyelids, and also what's the hot topic at the moment is changes in the brain due to the particle bombardment that we have in space.
So space radiation is the number one showstopper for deep space, human space exploration. Cosmic radiation is a main issue that we have to, and a main concern that we have to study with much detail before we are able to send astronauts for very long-term missions to the Moon, to Mars, but also to different planets thereafter. So for me, the conclusion of the session is really to tackle and to study even more the impact of space radiation and to develop countermeasures.
So the problem in space, in principle, is radiation. It's completely different to what we have here on Earth. It's a different kind of radiation, and we need to find how to shield human in space. Because in principle, at the moment, it's very risky to go in space, to travel in space because of radiation. So there are different possibilities to shield from radiation. There are passive shielding, active shielding, that at the moment there are a lot of scientists studying how to shield, let's say, astronauts from radiation. But we are investigating a new approach, that is this synthetic hibernation, that, as I say, is not an artificial process, it's something natural. We just try to find out how to do hibernation in not hibernating animals and in humans. And this will help a lot, because in principle we find out that natural hibernation increases a lot the radio resistance of animals.
During my presentation, I elaborated on the hind limb unloading model in mice. So here we look at the different stress factors in space, which are namely ionized radiation, microgravity, and chronic stress. With this model, we hope to investigate the different health effects that occur in space to pave the way forward to the future exploration of humankind in space.
In my presentation today, we were talking about how to take advantage of the ionizing radiations rather than being all the time afraid of it. We are trying to set up a protocol that can be used in space for the decontamination of the International Space Station, for example, or any other manned space facility, to limit the growth of bacteria and the growth especially of biofilms that may represent a life-threatening hazard when they are growing in an uncontrolled manner inside these systems of such space facilities.